So question 7 from topic time period. A student investigate the period of oscillation or a vibration in figure 1.1 and 1.2. You can see the arrangement. A student measured the distance D that was from the bottom of a clamp to the floor. This total distance was 120. This distance remained constant throughout the experiment. So this total distance is 120. He adjusted the length of a pendulum to be 70. Calculate the distance x between the center of the pendulum bob and the floor and record in a table 1.1. So if this total distance, the D is 120 and the length of the pendulum is selected 70, how much is this x? What's the value of x? Total is 120 and out of that 70 is so that's equal to 50 and the unit will be in centimeter. And we have to record that in a table. So as I mentioned here, record this in a table. So we'll write here 50. But not 50, we'll write 50.0 because it should be same number of decimal places you should use or significant figures for the result. So even though it's 50, but we'll write as 50.0. Then a student displaces the bob slightly and release so that it swing and shown one complete oscillation. He measured and record the first in the first row of a table for 10 oscillations. Calculate and record the first in the first row the time period, time for one oscillation, then t square, and then complete the column heading. So that we have to complete. So this is t. If this one is t, what will be t square? What is the value of t square? If this is t, not the column heading, first we have to complete this part. First we have to complete the value for t, the time for one oscillation, and this was the student recorded the time for how many? 10 oscillations. So here we need for one oscillation. How much is this? What's the time? If this is the time for 10 oscillation, which is 16 point. So time for 10 oscillation is 16 points. So we should divide it by 10 to get the time period. So it will be 1.67. 1.67 seconds will be there. And then t square, like 1.67, you just have to square that. So that's equal to 2 point. But you can see two decimal places are there. So this number should also be 2 decimal. So it will be 2.79. Yeah, so that will be 2.79. Now complete the column heading. What is the unit of x? So x is in centimeter. What is the unit of a time? Seconds. Unit of time square will be second square. So this will be second, and it will be second square. Then he repeat the procedure, and now we have to plot a graph for t square and x. So what are the values? As we have to plot a graph for t square and x, or I can write x first. So x and t square. So it was 50, 45, 40, 35, 30. And the value for t square 2.79, 2.99, 3.20, 3.39, and 3.61. These are values for t square. So first thing, you should always label the axis on y-axis. This should be like y-axis is t square, and on x-axis is x. And they mentioned you do not need to start your axes from origin. So we don't have to start with 0, 0. Like we don't need 0 on the x-axis or on the y-axis. So t square, this will be capital T square, not the small one, because it's a time period square. So this I should write t square. So t square, and the unit will be second square. And here we have X and the unit was in centimeter. Now, what is the minimum value for X? The minimum value is 30 and the maximum is 50. So if I start, like example, if I say this is 30, this one will be 40, this one will be 50. So between them, like there will be 35, this will be 35, this will be 45, and this 55. So we have to select an axis, like stretch the axis so it covers 70% of the graph paper. For for y-axis, the minimum value is 2.79 and the maximum is 3.6. So if I start with example 2.7, then 2.8, or like 5 boxes, if I select 0.1, so 1, 2, 3, 4, 5. So this will be 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6, 3.7. So we cover like 70%, more than 70% for both axes. Then we have to plot the result. So when it is 52.79, so 52.79. So this will be 2.72, 74, 76, 78, 2.8. So between them will be 2.79. 45 is writing the scale in pen must? No, you can use a pencil to write the scale, because and you should write with a pencil, because for example, sometime when we select a scale, maybe we think that we should change the scale, so you should always write the scale with pencil. Later, once you are done the paper, you can write with a pen, or even it's not necessary. Like you write the scale with pencil, you draw the graph with pencil. Graph should be with pencil because you have to sometime erase. No need to use pen on the graph. Later, like once you are done with whole exam, if you want to label the axis with pen, then it is fine. But always do the graph with pencil. Then it is 45 and 2.99. So this will be 2.99, which is about 3. Then 40 and 3.2. So 40 and 3.2. Then 35 and 3.39 of about 4, somewhat here. And then 30 and 3.61. So 3.61 will be here. Now what we have to do, we have to again, look, when I say line of a best fit, when you join all the points on the line, that is also a line of a best fit. When all the points are coming on the same line, so that is also a line of a best fit. So example, when we draw, all the points are coming on the line. So this is a line of a best fit, like it fit all the points. That's the best fit line. So this is the graph which we plot. The next part they ask, state whether the graph of t square and x is proportional and give a reason. First thing, are they directly proportional? Yes or no? Directly proportional. If directly proportional means if you are increasing the one quantity, the other is also increasing. So, and what will be the shape of the graph? The graph will start from origin. So I can I say that t square is proportional to x? Yes or no?
No.
So the answer is no. Yeah, we did not include. No, it is not inversely proportional. If two quantities are inversely proportional, then what should be the shape of the graph? It will be a curve when two quantities are inversely proportional. Even though we did not include the origin, we did not include 0, 0, but it's still that if the graph is like this, even if there was an origin here, but the graph is like this, it means that it is not obeying the relation that straight line passing through origin. we cannot identify it as passing through origin, but it should be a straight line. And if one quantity is increasing, the other should also increase. In a proportionality relation, if we are increasing one quantity, the other should also increase. If we are decreasing one quantity, the other should also decrease. But because the shape of the graph is like this, so it can never start from origin. It can never pass through origin. So what should be your answer here? As they asked to find students state a relation, state whether the value of a t square is proportional to x. So statement, what we will say no. Why? Because it's the straight line cannot pass through origin. This straight line cannot never pass through origin. Why it can never pass through origin? Because the shape of the graph give you an idea that it can never, like the graph is like in this manner, this line which we draw, it is like this. So how it will pass through origin? It can never pass through origin. So whenever two quantities are directly proportional, there should be a straight line, and that straight line which start from origin, we say they are directly proportional. And the directly proportional quantities means if x is increased, if one quantity is increasing, the other should also increase. If one decrease, the other will also decrease. But if this relation, some students think that this relation is an inverse relation, that is also wrong. This is not an inverse relation.
Inverse relation will be a curve.
Yeah. When two quantities have an inverse relation, then there will be a curve between them. This is called only a linear relation. Linear relation means when two quantities, the graph is a straight line, we don't say they're directly or inversely, so we simply say they are linear relation. So explain why timing the 10 oscillation give a more accurate result than for one oscillation. So if we record the time for 10 oscillation, we get, so best answer for this, it reduces the percentage uncertainty. So this is the best answer. Whenever a question is there, why, when we carry out the experiment or do the experiment multiple times, like for more swings, how it will give us the result accurate. So it reduces the percentage uncertainty, like, or the error is less significant error is there, or error is spread out over the 20 oscillations. Is it clear, this question?
Yes, sir, clear.